Hello, everybody. Welcome to my talk, Retiring the Singleton Pattern, Concrete Suggestions for what to use instead. My name is Peter Muldoon, and I am a software developer at Bloomberg and have been there for a number of years. Some of my history was that I started C++ around 1991, right in the very early days when it was just coming out. And I was a consultant for about 21 years before joining Bloomberg. So I've seen quite a bit of what goes on in the industry and been around C++ for quite a long time. So first things first, what we're going to do is I'm going to take questions probably at the end, but if you do have a question, please use the slide numbers there at the bottom right. Any question that has a slide number, I can usually get to it and answer it a lot more quickly than from hunting around the slides. So the motivation for this talk happened when I was in a project, and one of my sister teams, they were making a change, and we get email notifications of changes that are going up for review, and I seen the word singleton in the title. This kind of caused me to stop for a moment and say, why would we introduce a singleton? And when I looked, it said, singleton has been introduced to improve efficiency. So I was just a short walk over to the guy who did the change, and I asked him, why did you put a singleton in? And it was like, this is a really good thing to do. It makes things efficient. I'm not creating numbers of these. And when I asked him, singletons are kind of bad for a number of reasons. It didn't seem to have any traction because it was in a legacy code base. It's okay, it's in a legacy code base. You can maybe be forgiven for that. But within the week, in my own team that I was in, where we were writing brand new code, I noticed one of our developers was writing a singleton class. Just as I was walking by the desk, I seen singleton on it. And again, I said, why would you introduce a singleton in this brand new code base? So, we apparently know better these days. And it again was we're hooking legacy code base into the new software we're writing. And the only way that we can have them do this is by putting a singleton in, because we can't have them supply all the dependencies and parameters that we have for a brand new interface. So I did ask at that time, can I just take this problem? I'm sure there's got to be a better way of fixing this than, adding singletons into brand new code. So what I did was I went out onto Google, took a look around, and it seemed to be about half of what I was seeing out there was how to do a singleton pattern properly. Here's how you do it, tutorials. And about the other half was roughly saying it's a really bad thing and no one should use it. And one of the really good talks I came across was one by a guy, Mishko Hevery, the Google Clean Code talks. And he talked about how singletons introduced global state and how it led to a form of code insanity, in that you can do the exact same thing but get different results. And you have no idea why. There's spooky action at a distance, and what are we going to do about that? So kept on looking around, and I found this conversation in Stack Overflow, which was, what is so bad about singletons? And some guy who hadn't, I guess, been doing C++ very long, and said, I found the singleton pattern, I see how it's used, but everybody keeps saying not to use it. Why is that? And there was a lot of people saying you shouldn't use it, it's bad. But this sentence that jumped out at me, the worst part of this whole topic is that the people who hate singletons rarely give concrete suggestions for what to use instead. And it's true. I've seen no example of how you can do something different and get away from using a singleton. So this is why I decided to go ahead, dig up a way of doing this, and see where it got me. All right. Now, when I say a concrete suggestion, I actually mean a practical suggestion. In the Clean Code talks, one of the audience asked, I have a widget on screen that carries error messages. Every place needs it. How would I get around not using a singleton? And really, it was like you need to refactor the whole code base to not use a singleton, but no real hows. And I think when you say refactor a whole code base, it's not very practical. I'm actually in a project right now where we're rewriting an application and we're 3 years in. So I wanted to give advice that would be usable in a week, 2 weeks maybe. So the talk outline, I'm going to go over this very briefly because I have a lot to get through. We're going to take a look at the singleton pattern just to refresh our memories what it is, or who hasn't seen it before can get an idea of what we're talking about. And then we're going to take an example function. And this example function is very close to what was my first attempt at getting rid of a singleton. And we're going to do it in a way that the users of your function do not need to modify their code. At least they don't need to modify it right away. And I found when I did this, there was a lot of real world problems. It sounded pretty simple from the get-go, but you have non-copyable types, delayed construction, phase introduction, initialization orders, dependency groupings. These are all real world problems I came across, and I'm going to show you how I got out of those particular holes that were dug. And then at the end, we're going to look at some of the covered topics and questions. All right, so let's get to it. So first of all, here is the classical singleton pattern. The notable characteristics of this singleton pattern is that there is a single global instance of this type. Its copy constructors, assignment operators are either private or deleted, so no one outside this class can call them. And there's a single globally accessible method that gives you a singleton pointer back. That's the instance method. There is no way of creating a second singleton, which I guess is kind of the point. Some of the problems with having a single global instance is it holds the global state for the program lifetime. All right, there's no creating this singleton for a test and then throwing it away and creating a new one to try another test. That's all out the window. The initialization is out of your control. Right, you can't do any of this, and because of that, these things are opaque to testing, unless you do some fairly dicey stuff like put in backdoors or define private as public, stuff like this. Also, you find a lot of times in these singleton patterns, there's an init function that's again global, and the idea there is that will be called at main, and maybe it will set up some of the internals to make this thing work properly. But you have to know about it, and you have to know to call it before you do anything else. There's nothing explicitly saying that that needs to be done. So the drawbacks of a singleton, these are kind of well known. They act as hidden dependencies and functions that use them because I can just reach for that instance function from anywhere. There's no apparent evidence looking at header files that there's a singleton in there. And because of that, there is no dependency injection for testing. So these things tend to not get tested, or they're sent off for systems testing only. So your QA department does it. The initialization, again, out of your control. You can ask for instance, and that's all you can do. Multiple runs will yield different results because state is inside of that. And not only is state inside your singleton, but any other class that you create, anything else you touch in there that holds state, it's transitive, will also hold, have that state inside of it that will make your results differ. These singletons, once used by, and they were used a lot in the early days when the Gang of Four gave them legitimacy by stating it as a design pattern. They're usually in groups. There's a lot of them in the code. Legacy code in particular is generally riddled with these things as the code grew organically. And again, the state is tied to program lifetime. Function calls generally will have to be made in a particular order. I know when I first joined Bloomberg, I went to get some data in an object I had, and nothing came back. And I asked around in my group, and it was like, oh yes, you must put an init call in the main, and then another call has to happen someplace else to actually put data in there for you to get it. None of this is annotated in the interface. None of this is easy to find unless you go and look at the implementation. So you might ask, with all of these drawbacks, why on earth would anyone use a singleton? Well, they're darn handy, that's why. If I'm in a code base where I'm down at the bottom of a 30 layer call stack, and all of a sudden I find I need something, I don't know, to send data out on an MQ. My options are to either make a singleton where I can just grab an MQ instance and use it, or I have to now pass that down through all those 30 functions. And it won't just be 30 functions you touch. It's anything that dovetails into that function will also need these parameters added. So that's an internal reason for why you balk at doing a change where you pull the singleton out. Another reason is externally, other groups may be using your library. They're either linking into it or you're shipping them a shared library. They're calling into your API. If you change it, their code breaks, and they may be unwilling to change their function calls. They don't see this as a priority. It's not a big deal for them, or it's such an old piece of code in their system. No one really knows how it works anymore, and no one really wants to get in there and find out. And lastly, efficiency. I only create one of them and reuse it. I would maintain if you only need one of them, only create one of them and reuse it yourself. All right, so the point of a singleton should not be to grant global access to any particular value or data that you're looking to get control of, but to control instantiation of a type. And although this is pounded on by the proponents of singletons, they're a good pattern, they're just not used properly. However, it's frequently misused to just get easy access to global data. So now I have a quiz, and my volunteer partner is going to put a question in Q&A, and I'm going to ask you, is various things singletons or not? So first I'm going to show you is I have a limits file, and in that header file I have this external int that's a throttle limit. Somehow it's going to throttle how many tasks I'm doing at the moment, and I also have a function that returns get thread limit. Thread limit is, as you can see, just statically initializes one time. It figures out the number of threads I can allocate to a particular task, and that's all I'm going to use for the lifetime of the program. And also in the CPP, if you pull back the covers, the throttle limit is set to something constant. So who here thinks throttle limit and get thread limit are singletons or returning singletons? And if you go to the Q&A, you can upvote who thinks it's not a singleton or is a singleton. So please participate. We don't have an audience because we're virtual this year, and it's nice to get some feedback. All right, only 2 people, not 3 people. It is a singleton. All right, okay, so we're getting an overwhelming response that it is a singleton. All right, well, let me ask you another question. So question 2 on the slides. This is something from our own IO stream header, where we have CIN is declared as an external I stream, Cout is declared as an O stream. Who thinks that CIN, Cout are singletons? And who thinks they're not? So that's a new set of questions that my partner will put up there. Again, is CIN and Cout a singleton? Alrighty, I'll call time on that. You can stop voting. Fernanda, you can take the questions off the Q&A. So in actual fact, none of these are singletons, and I will explain briefly why. So throttle limit is an int. Get thread limit is returning an int. And CIN and Cout are O streams. I can create my own versions of these. There is no obligation to use the int that comes from get thread limit, for instance. So if I have a class that I'm dropping the get thread limit into, I could essentially, mock that out by just saying, hey, we're taking the int from someplace else and dropping it in. So I'm free to roll my own and use them. I do not have to use the int that comes back from the thread limit. So there is multiple ints running around. Anything that takes an old stream, I can create my own streams. They're mockable. You can create more of them. A singleton has only that one instance that you can get from the instance method. All right, so I'm going to move ahead. Send data. This is a function pretty close to one of the original functions I came up against, and it had a singleton buried down in it where a data was passed in. It had all kinds of information in it, which I knew. A request was created internally inside of the send data function, and the program did a lot of transformation, getting data from other places, concatenation, you name it. But it took data from the data structure and from other sources and cobbled them together in the request. And then it called this singleton instance that's with the request. Now, if I was to look at this diagrammatically, what I have is a send data function that takes data in, but has, like two outputs. So we have the response coming out that says, it went well, it worked, it didn't work, but we also have a request being sent. And even though the response might say it worked, I need to know, is the request proper? So how do I get my hands on this? All right. So let me see if I can get Singleton out of here, get some dependency injection going. But the way I'm going to do it is I'm going to have some requirements, right? So the first requirement will be the function has to be at least source compatible. That means any of the current callers of my send data function, they're not going to have to do anything. The change will be transparent, although they can make a change if they want to. I want to express the involvement of outside agencies. As Mishko Hevery said, functions with singletons are pathological liars. They make you think one thing when another thing is going on. So I'd like to say to some in the header file, there is some agency here that's using to send this request out. And then the big thing is, given that I have this, I would like to have dependency injection for the testing. That's going to make the code more reliable. I'm going to be more confident when changes are made in data transformation going forward. So here was my first crack at this. We take the singleton and we add it as an explicit dependency in the header. So now it's a 2-parameter function. But even though it's a 2-parameter function, my single parameter callers who just give me the data function are oblivious, right? I'm going to just still fill in by default the singleton itself, and then down in the function I'll use it. So it's not bad, but how have we done as far as our minimum requirements go? Well, the new function is source compatible. Anyone can call it with a single data value. It does express the involvement of an outside agency. Anyone can look at the header now and say, okay, there is something here that's doing ascending once this data is prepared. But I do not have dependency injection. I cannot put any kind of mock in there because the singleton is a single class. I can't derive off it. I can't virtualize functions on it. So I'm stuck. So what will I do? Well, let me go back to, I'm going to create a wrapper class to replace the singleton. Now, what am I going to do? This is not really going to be any new code, more like purloining the code that's in the current singleton. So what I'm going to do is say the constructor is going to have all the initialization code in it. So whatever was in an init call, or if it's in the instance call that constructed and set up the proper data inside of it, that's going to all happen in the constructor. Now, in the send function, I'm just going to lift all the operations that were there in the send function, drop them in the send function of my wrapper. Once I've done this, I can essentially throw away the singleton. I don't really need it anymore in my class or in my function. I have here a TCP client. That's just there because I actually had one in the function I was trying to get rid of, and these are not copyable. So this is going to cause me problems down the road. Now I'm also going to put this in the header file. So this is a statically created instance of the wrapper. I am going to need this for when other people won't drop their own wrapper in. So this will give me a default dependency. And again, who here thinks this is a singleton? We're not going to go to Q&A for this, but do you think wrapper is a singleton? Well, it's not, right? it's a single instance of CommWrapper, but you're under no obligation to use it. You can create your own, and I would actually hope you would create your own. This is just for the people who I can't convince or will not create their own. So now let me go back and see what happens on my send data function. So now I have a CommWrapper reference being dropped in. You see this in the header, declaration. And I'm going to give it a default of that statically initialized CommWrapper that's in service comm. Again, this makes it transparent to users of my code. They don't have to come in and say, oh, you've broken my code. I have to do this CommWrapper. What is this new thing? We don't want to do it. Okay, I'll make it easy for you. And then the rest of the function is just as before. So I do all my transformation of data. And now I have the send at the bottom to send the request out. However, have we got dependency injection here? And the answer is no, because I can only drop a CommWrapper in. And if I drop a CommWrapper in, it's only going to call the send function, which is actually going to send. So again, I can't get my hands on that internally filled request. But the fix for that is pretty easy, right? All we have to do is put a virtual on the send method, give myself dispatch, a runtime dispatch, and now anything that inherits from CommWrapper will be able to overload the send, and that's going to be key as far as dependency injection goes. So again, going back to my function, I will encourage people to create their own CommWrapper, but if they don't, I take my statically converted piece, drop it into the send data function, and now the whole thing just works. All right, no one has to make any changes, but I now have dependency injection. Well, I hear you say, Pete, where do you get that from? Well, let's look. So I decide to, by hand, write my own tester class. And I'm going to inherit off the CommWrapper class. And all I'm going to do here, pretty simple. I'm going to have a constructor that takes an outside reference to a request. I'm going to hold that request inside the class. And then anything that calls the send method on this is going to just capture that request, copy it into whatever request was passed into me, and then I'll return a regular response. So now in my test send data function, I can create myself a data record, populate it with known values. Here I've just done the ID, but I could do a lot more. And now when I create my comm tester, I'm just going to drop in the request, which will be inside a reference to this local variable, and I call the send data. The send data goes through its thousands of lines of permutating of data, putting it all together, and it will now be copied into my rec. And because of that, I can now do verification of what's in the request. So here I just check that the sender ID in the request is the same as the request ID. But I could do this for basically anything. The whole request becomes open for testing and examination. Now, in my group and across a fair part of Bloomberg, we use gtest. And using gtest, I don't have to roll my own testers. All I'll do is I'll create a mock client from the CommWrapper, and I'll say, look, there is a mock method that takes one argument. It's called send, and the signature is it takes a const request reference and returns a response. It'll look very much like before. The only difference is that I can now put an expectation on the calls to my mock client. And here I can say, if you look at the expect call, I'm going to have this A client. It will be called with a single argument. And once that is called, I want you to save that argument into the request and just return a default response. Again, I call my send data function with this data record. It goes in through all the data permutation, and my mock client will copy it out. And again, I have full access to what's in there. So what I've done now is I've traded a opaque to testing function for something that is much more testable. I get to sleep better at night. So I use a virtual function there, and in modern C++, virtual functions seem to be more frowned upon these days. So I was asked, what if I wanted to do it in a modern C++? Well, That's pretty easy. All I need to do is declare a stud function that again takes the same kind of signature as my comms wrapper has. So here I'm just going to take a response that should be a const request reference. And then in the header file, I'm just going to say the send data has a comms func called comms. And again, I can default it to the exact same thing as before. So again, my callers don't see any difference on this function. The call to send data now takes two parameters in the actual definition, right? But we've taken care of that in the declaration. And again, we'll just take the request and call the comms on it. So pretty easy. We also have a problem here. And this is a real world problem I ran into. I actually did all of this and I checked the code in, I got through review. And when it went out to production, it turned out that I was creating that TCP socket, and actually created I think, a couple of them, and the process forked for the terminal. And when that fork happened, it doubled the amount of sockets that was being using. And over the whole of Bloomberg, that was very noticeable. And I got a problem to take it back saying, hey, what's going on? You seem to have doubled the number of sockets we have opened. And it was because I was making copies. But we will get back to that in a little bit. So a copy has been introduced, right? It's been introduced right here. The comms func is making that copy. Because stud function does not use move semantics, it will copy it right in. We also have, other issues, and I'll talk about them a little later. So what do I do? Well, it's pretty simple to fix. All I have to do is give it a reference semantics, and std ref will do that. Std ref will create a reference wrapper, which is essentially, you can think of as a struct with a pointer to the service com in it. We don't have any lifetime issues because this was statically created. It'll be there for the lifetime of the program. Even though it's not a singleton, it's just a non-changing particular instance. We now do not have a copy. So we're all good. If I go back to my com wrapper class, I just have some modest change. I don't need virtual anymore. But because it's stud function, I have to overload the parens operator. There's no send method anymore. But more or less, it's the same as it was. Here again, I can mock out the client. The only difference here is that the gtest doesn't allow you to mock the parens, so I just have to do a little dispatch where I'll just make the mock method the same send function, and the operator will just forward it. And much like before, I create the client, I take my records, stuff it full of data, set the expectations in the call, they don't change, and then I call the send data. And I make sure I use the, I might have to use std ref if I haven't made the change from previous. One thing to note is Google Mock will not allow you to copy it. So even if your class was fine with having a copy made, and you may not have noticed it, when you drop it in here, it will complain and you'll have to put a std ref like I did there. But again, we now have a completely transparent function. So here we are, and this is looking at the modern C++ version of it. So I gave this talk previously, and someone came up afterwards and said, look, I would be worried about performance implications of copying the functor. So even though over here now, where I do the copy, I only copy a reference over. So I don't have to worry. Previously, I had to worry about not only the stud function being created, but I also had to worry about maybe the service comms is so big, the small object optimization inside of it is too small, and I have to malloc. So every time I call this, I could be mallocing out of this thing if I didn't have a reference here. But now with the reference, it's going to fit into that small object buffer. But still, you're creating that comms func each time. How can we get around that? Well, like anything, it's just a matter of another level of indirection, right? So my com wrapper impl is exactly the same as what my com wrapper was before. All I'm going to do is I'm going to introduce a new class that's called com wrapper. And the only function of this is to catch the stud function inside of it. So in the constructor, which will be called once in my get in my static initializer, I'll capture that function, I'll hold it as a member. And anyone that calls that operator parens, there'll be no copying anymore. It will just call the internal sender, but there is no virtual anymore. And the older client just takes a little change. I can't initialize it with nothing. I just initialize it with a default com wrapper impl. Okay, and then that means that my original function, even though it's in modern C++, kind of looks more like the the 03 C++. I just pass in a reference again, and the function being captured hides all that semantics. So again, it all just works. So after this, I did actually go to QuickBench and I whipped up a quick test, and I would not say this is something you should use in place of testing it yourself. You always measure, but I did run a quick test, and I did this no IPA, no inter-process analysis, which was trying to stop the compiler doing tricks. And I did it at 01. And the green on the left was when I used the method where I had the functor being copied every time the send was being called. The pink one beside it was the one that was called when I did not copy it, so I captured it in that extra level of indirection. So it was a little bit more efficient. The two at the bottom is when I did and didn't use virtual functions. And again, they're pretty close. I'm going to call it, based on Emery's talk, probably noise. And then there was the no op at the end. So as you can see, it's a little less efficient if you go the functor route. And if you know how to work underneath the covers, it's not that big a surprise, I guess. I also ran it on 03, and again, referring back to Emery's talk, this will cover 02 as well. You see that the green, which is the copying of the functor, again, is the top one, not by a huge margin, but the indirect capturing of the functor, which is in pink, is a little better. And then the other two, again, are roughly the same. So you can take whatever mileage you'd like out of that. So now, preserving the ABI. So let's look at our current solution. We have a new function. It is source compatible. No one has to make any changes, but they do have to recompile. And in my situation, that was enough. But again, people have asked me, what would happen if I was shipping a shared library? People are not recompiling every time a new library build is made. Well, then I have to keep this, the function signature stable. And if you look up on the processor.h, my adding an optional argument will definitely have affected the name mangling. This will break any shared object that you might have had previously. So how do I fix that? It's not really that hard. It's pretty obvious. Again, most of the code examples here won't be using cutting edge C++. If some of the other talks are using nuclear fusion, I'm pretty much using a Zippo lighter to do stuff. So here, all I'm going to do is say, instead of changing the interface of the function, I'm going to leave the function interface stable. I'm going to create two functions. I'm going to overload it. So the original function gets the two parameter overload. All the transformation, all the implementation of creating that request is going to be captured in the two parameter version. But I am still going to keep a single parameter version around. And that's only job is to dispatch it with a default, with the default injection that I want. All right. So as you can see there, it's a one-liner, send the data to two parameter function. This is going to keep my ABI preserved. I'm not going to have a problem. So great. Now getting back to problems I was talking about earlier, where I was creating a bunch of sockets, because what's going on here, I have this statically initialized piece. This is a potential problem, and was definitely a problem for me. The default instance is created before main runs. What that means is that when my process forked, it copied all the open sockets to the child and to the parent. And that's not what used to happen before when we had lazy initialization. We also have other problems. We might have static dependencies across TUs. In other words, we need to have a particular initialization of these things in a particular order, which you don't have if you have a bunch of these things. And this thing can happen, you need initialization probably prior to code being usable. So these are all problems I came across. And again, I just took the trick from the regular singleton method, where I just said, okay, let's use lazy initialization, because that's going to get me the same thing they had, which is I don't create it till I need it. So again, in pre-C++, and most examples have pre and post, because I think this is more applicable to legacy code bases, but I have seen it in modern code bases, and you know, you can take your pick of which one you're able to use. So in pre-C++ 11, here's how you would do it. You would just create a static pointer, set it to null, and then I have this get default. And this get default has a compiler do once macro in it. And if anyone wants to know what compiler do once does, it just does a thing once and once only. Prior to C++ 11, this was compiler specific, so I can't give you exactly. And it uses a thing called double check locking. So you could slap a mutex in there, but you would hit the mutex when you needed it the first time when it's been set up, and then you're hitting it every time after that, even though, which is the vast majority of usage, and that's a performance hit. So they had this double check locking where you would check the com wrapper pointer beforehand to make sure it's not being set before you try and acquire the mutex, then you check a second time. But anyhow, this is just a way to make sure com wrapper is initialized once and once only in a multi-threaded environment. Okay, and if you have modern C++, things become a little easier. They standardized what having a static instance inside a function will use double check locking correctly. And all I'm going to do here is in my get default comms, I'm going to say create me a static version of this client and return it. Okay, now who here thinks this is a singleton? All right, the get default comms is returning a singleton. Who thinks? Because this is maybe a confusing to people. So nothing returns a singleton here. It's a com wrapper. And again, you're free to use your own com wrapper. You can't, it's not just my version. I'm creating a version for the people who are unwilling to create their own version. All right, so it's not a singleton. So with lazy initialization, in my dispatch function, my regular 2-parameter function doesn't change at all. In my dispatch function, instead of using a statically initialized version, I do this call to get default comms. And this means that the first person to call it, it sets it up, everybody else just gets whatever was the instance when you call the single parameter only, not when you call the 2-parameter version. All right, so let's take a look at what we have done. So we've done something that I think is quite remarkable, even though it is maybe using simple coding techniques. We have taken a function that had hidden side effects. In this case, it was a singleton setting out the request. And we've done something to it. We've said, look, I create a function with a dependency in it, which is what I wish I had originally, but I don't. So this is kind of retrofitting. But I now have the exact function I wanted originally. It's got dependency injection. I can test it. I can set up a bunch of unit tests. I have confidence this function works now. And for my legacy users, I just have a dispatch function. And this dispatch function is just saying, look, I'll give you a default if you don't want to supply one. And then I'm going to just dispatch it to the 2-parameter function. So we've separated the concerns here. I only really will want to test the implementation. The other one is, I'll say, uninteresting in that it sets a default. If you want to check that a default is set up properly, that goes someplace else in the code. You don't have to do it. You shouldn't be doing it here. But we have separated construction and dispatch for our, I'm going to say, legacy users from the function with all the dependencies in it. And I think that's a marvelous thing. And it allows you to sleep better at night. And in Bloomberg, that's quite literally. You don't get woke at 3 a.m. in the morning from a problem from London with some code bug you introduced. But let me get to, I think, one of the biggest problems with this is that I go along, I take my send data function, I've converted it now to use these wrapper functions, I've thrown out the singleton. Life is good. However, turns out that in another place in the code, or maybe there's 100 places or 150 places in the code. Other functions are using this. It's not just a single-use singleton. So other places are using this. In this case, we have another xData function. It takes a different type of data, but that gets transformed differently into a request and sent by the CppSingleton to wherever it needs to go, which will handle it and return a value. Now, fair enough, it's one place this is happening, but this might be happening in hundreds of places. And in fact, I showed this to a colleague, and actually he showed it to me where he had this exact problem. And he was like, I'd love to use this pattern, but I can't really use it. I mean, the only way I could use it is if I have the get default comms return the CppSingleton instance, which seems to be kind of redundant. You know, I mean, I guess if I do them all, eventually I can do it, but it really is not something I'm willing to do. It's too big a lift, and this becomes a real problem in legacy code. You try to do a localized change, but stuff is just not coupled properly. And, you know, you would have to go and touch the whole code base. And I'm looking to touch 3 files, not 300. So what can I do? Excuse me. Well, if I come back to the CppSingleton, here's our singleton pattern. It's been upgraded in 03 to handle multi-threaded with the 2 ones. But what if I was, well, you see elsewhere at the very bottom of that slide, this is how people call singletons. They call the instance and then the method directly. They don't save the pointer off. It's just so darn handy you can call it this way. So what if I was to change the singleton from returning itself to returning my default comms wrapper? And so again, let's look at that. I went from having an instance method that's returning a member function, well, not a member, but essentially a captured member once, to just returning my default comms. If you look at the bottom elsewhere, people won't notice the difference. CppSingleton instance, when it calls the send, will just work. And this is really nice, right? What it means now is in my send data function, I have dependency injection. I can test it, sleep well at night. But in the 150 other places that singleton is being used, I can just leave it as is. Now, there won't be dependency injection there, but it's ripe for dependency injection when someone gets around to doing it, which maybe never. And if that's the case, okay, maybe you can live with that. And then I just want to, and I haven't been checking the chat, but I just want to make sure that we include slide numbers. There will be an AMA session after this for questions if I don't get to answer them within the hour. But please include the slide numbers. Now, when I have the traditional singleton approach, there is generally not going to be a single singleton. You can probably count yourself blessed if that is the case. What happens is a singleton will usually reach out to another singleton. And here I have a comms, and it's going to reach out to a cache for some reason. This cache reaches out to a DB singleton. And this DB singleton gives it persistence or whatever. It doesn't really matter. So I now have a dependency that is, I'm going to call it length or on the x-axis. What am I going to do? Well, currently what happens in main, I have to call these bunch of init functions, because if I try and do a comm function without a cache without a DB, I don't, at best it blows up, in which case I'll know the problem pretty quickly. Or at worst, it somehow corrupts and doesn't work properly. Oh, but look, I made a mistake here. I actually got the order of initialization wrong. Right? I created the CppSingleton first when I must create the least dependent one, or initialize the least dependent one first. So really, I should have done it this way. And this is just the exact problem you face. And you know, you have to know the voodoo or the magic incantations in the main that sets all these things up. So what if we were to go a different way? So the DB wrapper has no dependencies. It's already covered. But let's look at the cache wrapper, which needs a database wrapper set up. So I'm going to take my database wrapper and make it an explicit dependency of a cache wrapper. You can't create the cache wrapper without the DB wrapper. All right. And we still have the save function. The comms wrapper, again, has a dependency on a cache wrapper. We'll make that explicit. So we'll put that in the constructor. Cache is dropped into the comm wrapper. You can't create it without one, so the cache wrapper would have to be initialized. And let's see how that's going to work. So in my get default comms, I say, okay, there's a static comms wrapper, but it does need a default cache. So I'm going to call a get default cache function while I'm in trying to construct my comm wrapper. That goes to the get default cache. That tries to create a cache wrapper, which must provide a DB. So that calls a get default DB. And then I have the get default DB. So the cache says, okay, I need one of these to get, the database wrapper has no dependencies. So it creates the wrapper. That rolls down to the cache. The cache now has a fully created default DB. So the cache gets initialized. Then we drop back into the comm wrapper, which now has a fully initialized default cache. So what we have done is we have swapped out using a particular hidden recipe in main to explicit dependencies based on the constructors. So the constructors will ensure it's done in the correct order. So great, it's going to be hard to misuse now. You're not going to be able to create a comms wrapper without the other things being initialized because you're just not going to be allowed. The language will take care of it for you. So how do we mock these things? Pretty simple. All we do is we create inherited mocks from all of these that take the same kind of mock methods. Again, I'm going to create the various, like the mock DB client. Then I'm going to create the mock cache client and pass them my mock DB in. I'm going to create a mock comm client, pass the mock cache in. So now that whole dependency is all set up. Again, I'll set my expectations. I can have 3 different request types depending on, I keep them the same here just to fit on the slide. But as you see, I can set my expectations. And when I call the send data call, the comm client is going to reach in there, hit my mock, and my mock is going to take each of these and put them in the right spot. So it all just works for me, which is great. And then when I come out, I'm now able to interrogate the comm request. I can actually interrogate the intermediate request if I want as well. So I have a fully testable system from something that was hard to use to something that's hard to misuse. All right, now in reality, we also have so if that was length or y-axis, we're going to have our x-axis, we're going to have the y-axis, which is depth. If you think one singleton per function was some kind of limit that was imposed in the early days, it was not. If someone used a singleton once, it was so damn handy, they used it many times. So there's going to be many of these singletons, and I'm going to replace them with the equivalent amount of wrappers. So how do I pass in a group of dependencies without a lot of boilerplate, and be kind of natural to how we code? So this would be the dependency graph here. They don't depend on each other, but my function does depend on them. Well, we can use brute force. And this was frequently used in functions where you just say, I need an X parameter, and that's why when you go to legacy code, you'll see 15, 20, even 30 parameter functions. So here, I now have a 5 parameter function, my original data member, and each of my wrappers. Inside of that, I'll just call the DB, I'll just call the save on the DB and the cache, I'll call the send on the MQ and the comms, and it will all work. My dispatch function will be a little bit long-winded. All these get defaults will have to be in there. And it's hidden from the user, true, but I think this is probably not the way we'd like to go. So normally we would just reach for a struct and say, let's just put a bunch of stuff that doesn't depend on each other, but they do need to go around together, and drop them in a service struct. And then instead of having a bunch of get this, get that, just have a get default services, which says, hey, create me a services, which will have one of the wrappers, per operation in it, and use it. And then I just go back to my send data function and say, okay, now there's just a get default services in my dispatch function. That's how we're going to inject the default dependency for people who won't use my 2 parameter version. And then in 2 parameter version, I just call the saves and sends as needed. However, that does not have dependency injection, all right? I can only drop in a service, and that service has preformed the individual services inside of it. I don't get a chance to get in there and do a mock. And even if I do, it'll get sliced and it will call the original send or save function. So a perfect time for templates. I mean, this is what templates were made to do. So now I have a service type being dropped into my send data function. And as long as that service type has a DB underscore cache, an MQ, and a comms on it that have these required operations, it'll work. All right, the compiler will see, look, in the dispatch function, which will be in the CPP file, that I have the send data that is calling another function that's a template with a default services, which will resolve to a services struct. And this does all work, but you will have a problem because I want dependency injection. And to get dependency injection in here in a CPP file, I can't do it. I would need to change this to a mock, or not change it to a header file. And if you have a legacy file that has thousands of lines in it, all kinds of nastiness and tricks that were used in, I'll call it the old days, all kinds of file local functions, you have no shot. I mean, you have absolutely no shot of turning it inside out to be a header file. And that's going to stop people doing what I'll call the good of removing the singleton. There is a way to do it. It's a bit unorthodox. What we would have to do is in our production header, we would have to include our mock service definition. And then we would have to say to the compiler, instead of you implicitly knowing that you need this, I'm going to explicitly tell you, I need a version of the send data that is templated on the mock service. And then over in my test suite, when I try and link, I'm going to have the linker's not going to complain. I'm going to have a proper send data version. This is a little unorthodox, putting a mock service header into your production code. It might raise eyebrows if it's legacy code, it might not. Either way, this is trying to fix something that you really probably shouldn't have gone down this road. This needs to back up. We don't need to try and fix a problem. If we're in a hole, you don't keep digging, right? You hop out of the hole. So what I'm going to do instead is I'm going to say, let me use it. My struct is going to have references in it. And references will allow runtime dispatch in the pre-C++11 world. And if you're in post, you can just use aggregate, or even you can do aggregate initialization, or you need to have that constructor. But doing it this way, now all I do is I say, okay, create me a static instance of each of these inside of my get default, and I'll initialize my static service with it and return it. Again, no obligation to use this service. This is not a singleton. You can create your own, and I would hope you would create your own, but if you don't, I'll have to give you one. Back in our function again, all we're going to do is, right, we'll drop these things in. We have the save and the send. They're going to be called on the DB, the cache, and whatever, but it's going to use runtime dispatch. So if I use mocks, I'm going to hit the mock function. So now I have dependency injection again. How do I do that? Well, I'll have to hurry, but you just create a bunch of mock clients derived off these things, drop it into a services, set up your expectations so you get all the requests back. And then I call the send data with the services. That's going to, inside the send data, reach into my services, hit my mock functions. And again, all those requests are available to me. So I have dependency injection. If you have modern C++ and you want to use type erasure instead, again, same thing. You just have a service. You fill it these out, and the call functions are all the same, but they could be different. And if they are, no big deal. Inside the default services, again, create my static instances, just initialize the service, again, using references. So we have reference semantics, and then we push the service back. And again, it will all work. The only difference between this and the last slide is that I'm using the parens operator instead of a named send or save. So great. Now, I've gone back. Here's my send data function. I've gone back and I've actually updated my send x data function. I was a good programmer. I remembered it. So I went back and I now have the two parameter versions of the functions. And I have a dispatch function for I call them legacy users, or the people, which might be myself, but the people who don't want to change the code. But what if this thing happened to be inside a class? I had a send processor. There weren't free-floating functions. Sorry to the functional programming crowd, but they happen to be in a class. Well, now I can factor out the services. I notice a pattern where I might have 20 send functions, but they all take a services and some kind of data, or the original inputs. So what I'm going to do instead is I'm going to say, listen, let me capture that services in the constructor. So I'm going to have a default constructor. That default constructor is going to, here we use a delegating constructor from C++ 17. If you didn't do that, you would just have a setup function inside. But either way, the services is initialized via the constructor. And if it's initialized via the constructor, I don't need dispatch functions anymore, because I don't need to say to the person calling the actual send, you need to pass in my dependencies, because my dependencies were captured in the constructor. So now what happens is the functions go back to looking exactly the way they did before. Right? Again, ABI should be good. I can't promise it, but ABI should be good. And internally, you can either leave those 2-parameter functions as private functions if you want to just annotate your code maybe, or you can just use them directly, right? That's the idea of having private class data. And with stateful dependencies, we set up the client exactly the same as before, nothing different there. Set up the data record exactly the same as before. And then the only difference will be here is where I drop in my dependencies. So this is a service with a bunch of mocks in it here. And then I call the processor send data with my record. And that's going to, again, somewhere inside of there, call these services. And now I can interrogate each of those requests. And not only that, I can check each of the functions out. I would say here we should have a separate sendX data function just for brevity. That's what I'll keep it at. So now we have all these interdependent singletons, groups of singletons. You've gone and you've replaced them with wrappers. So someone used to have a biz singleton because it was so handy. Now we now have a biz wrapper. That can have a group of dependents that are cache wrapper, TC-val wrapper, whatever, tran wrapper, you name it. The dependency graph, it doesn't really care what shape it's in, right? So they can be interdependent, they can be grouping, it doesn't really matter. We've solved the width and the depth and the width of dependencies and have it work naturally. In other words, it's really hard to use this wrong now, where I'll say that the singleton not only took away your dependency injection, or actually you never got it, but you now have much harder to misuse code. And that means, you'll generally sleep better at night, at least I do. And that's, again, quite literally. So we looked at replacing singletons while keeping it both API source compatible. That may be enough for you. If you need ABI compatibility, I showed you how to do that again. And actually later on, it turns out that just the better way of doing it with the lazy initialization function will keep it API compatible anyhow. We showed you how to get away from problems I had, right? Where I had copies being created and it turned out it had elements that I copied over from the singleton that couldn't be copied. Delayed initialization, again, that was a little embarrassing. And the phased introduction, I think that's a big one. That's one where it allows a person to take a bite-sized chunk out of this problem instead of having to take the whole global singleton use into account. And again, using features of the language, pretty standard. We can have the initialization of interdependent singletons mandatory now. Because it's interdependent wrappers that use constructors, it's going to just work for you. You can't use it wrong. The grouping of multiple dependencies, again, we can put the wrappers together very naturally, so we don't flood a signature with a bunch of extra arguments. And in the end, we talked about stateful. If you're using classes, you can actually, it turns out that only the constructor even needs to be touched, and that's, that's a great thing. We did all that, and we created testable code. And testable code is to me, the big win here. If you've been relying on a QA group or something else, it's a very long feedback loop from there's a problem, go fix it. There's a problem, go fix it. If you have testable code, you catch the vast majority of those in, when you're writing them. And if you do find a new problem, you update the test, it highlights the problem, and then we never see that problem again. At least we shouldn't. So how has this worked out? Well, it's worked out pretty good. What's happened is that when I originally was just telling people about doing this and showing them, my take on doing it, people started using it. Even that first one where you drop the singleton in explicitly, I've seen people doing it, even though to me that's far short, but at least it's adding expressiveness to the code, and the uptake was pretty good. And as I've said, as I've given this to wider and wider audiences, I've had people come back and ask me, hey, how would I do it for this and how would I do it for that? And the other thing I just want to finish off, and then we'll get to questions, is that this does not just work for singletons. This works for, let me say, values that roughly don't change through the life of the program. I had just a dependency that was hard-coded into a function to do with metrics. So we have timing and duration and counts, and it had a char function that said this is the metric I'm measuring. But then it turned out we had to run it in various environments and legacy, and both in prod. And now you needed a context, and that was always there, but we had hard coded it. To lift that out and make a 2-parameter function would have caused a wholesale change in the code. But I just lifted it out using this pattern. It wasn't a singleton. It was just hard-coded value inside of it, and it works. So, as I say, here is my email, and we will now go on to questions. I will say we're having an AMA session, so this video is not going to cut out. If you're on YouTube, it probably will, but you can also, I will check back in the comments periodically if you want to leave questions, or you can contact me directly on Bloomberg.net email there.